The James Webb Space Telescope, cracks in our universe. Collapsing under the weight of new evidence. The James Webb Space Telescope, designed to peer into the earliest light of the cosmos, has now delivered data so unsettling that a Nobel Prize-winning physicist has broken his silence with one simple, terrifying message. This is not our universe. What exactly did the James Webb Telescope find at the very edge of everything? And why are scientists warning that it could rewrite the very foundation of cosmology as we know it? Keep watching because what you're about to hear changes everything. In a corner of the sky filled with ancient light, the James Webb Telescope captured what looked like a simple yellow splotch. But when astronomers took a closer look, their assumptions collapsed. That tiny glowing blob wasn't just another galaxy. It was the most distant galaxy ever seen. Formed just 290 million years after the supposed birth of the universe. But here's the impossible part. It's too massive, too bright, and too evolved to have formed so soon after the Big Bang. By our current theories, there simply wasn't enough time or matter to form galaxies like this in the early universe. And yet, here it is, and it's not alone. Webb has now found dozens more just like it. Each one is a cosmic paradox, breaking every rule we thought we understood about the early universe. Scientists began to dig deeper, and what they found was even stranger. Some of these early universe objects aren't just massive. They're completely foreign to anything we've seen before. Unlike normal galaxies, which convert about 10% of their gas into stars, Webb discovered at least 3 galaxies that have turned 100% of their matter into stars. No gas, no dust, just pure blazing starlight. That's not just unusual. It's impossible according to every existing model of galaxy formation. So now scientists are asking a far more terrifying question. What if these aren't galaxies at all? What if we're not seeing the early universe, but something else entirely? A structure from another dimension, a remnant of a previous cosmos, or an intrusion from another universe altogether? To understand why this is shaking cosmology to its core, we need to talk about the Hubble sphere and the observable universe. The farther away an object is, the faster it moves away from us due to the expansion of space. At a certain point, called the Hubble sphere, galaxies are moving away from us faster than the speed of light. Common sense says we shouldn't be able to see those galaxies. Yet, we can. That's because space itself is expanding and the boundary of what we can see keeps stretching. But beyond that boundary lies something terrifying. A region of the universe that we will never reach and that will never reach us. And yet the James Webb Telescope is now picking up light and signals from these impossible zones. Light that should never have reached us. Which leads to one conclusion. We are seeing beyond the edge of our universe. And no one knows what lies on the other side. Webb's data is forcing scientists to ask the unthinkable. What if the universe never had a beginning? Some Nobel laureates are now openly questioning the Big Bang model. Because if galaxies could form faster than physics allows, if light can reach us from beyond cosmic boundaries, and if structures appear that defy time, scale, and mass, then maybe we've misunderstood everything. Maybe the early universe isn't early at all. Maybe what we're seeing isn't a timeline, but a fracture. A place where 2 universes overlap, or worse, where something far older than our universe is bleeding through. Whatever it is, it doesn't fit into our models, and it never will. Among the James Webb Telescope's most overlooked discoveries is not a visual image, but a strange frequency. While measuring the background noise of the universe, Webb's instruments detected a faint rhythmic oscillation, one that does not match any known cosmic phenomenon. It's not a pulsar. It's not gravitational waves. It's not cosmic microwave background distortion. This frequency repeats at precise intervals as if it were generated. Some astrophysicists have started calling it the heartbeat beyond time. Others are more cautious, suggesting it might be a signature of exotic matter, something that could exist only outside the boundaries of our universe. And here's the chilling part. This frequency is not random. It follows a mathematical pattern as if something or someone encoded it to be discovered. One of the telescope's unexpected findings is a huge imbalance between what we see and what we feel. Galaxies located at the farthest distances appear to have enough gravity to bend light, distort space, and even affect surrounding structures. Yet, no visible matter is present. This isn't just dark matter. It's something else. Some researchers now believe Webb is detecting massive gravitational anomalies that don't correlate with any known source. These phantom mass fields act like cosmic fingerprints, pressing down on space-time from a place we cannot see. But where are they coming from? Some theorists are beginning to suggest the unthinkable. We're seeing the shadow of another universe colliding with our own. What if everything we see has a mirror image we cannot see? Not metaphorically, but physically. A fringe theory once dismissed by mainstream cosmologists is gaining traction again. That there exists a mirrored universe where time flows in the opposite direction and the laws of physics run backward relative to ours. What's changed? The James Webb Telescope has captured evidence of particle behaviors and rotational patterns in distant galaxies that suggest a symmetry, as if two different cosmic systems are overlapping. It's as though our universe is being pulled in one direction while another one just out of reach is moving in reverse. If true, we may not be alone in the multiverse. We may be entangled with a shadow reality that reflects our own. In a final twist, one of Webb's long-range instruments was tracking a light signature from the edge of the observable universe. It was expected to fade. It was expected to disappear forever, as most light from distant sources eventually does. But then it reappeared, not from the same direction, not from the same time, but with the same spectral fingerprint, as if the light had been sent out and bounced back from something. The telescope had just observed a cosmic echo. But echo of what? There are only two possibilities. Either the light circled back around the curvature of the universe, which would imply that space is finite and closed, or it hit something else, something at the very edge, something capable of reflecting light, something that shouldn't be there. Its proximity makes it personal. It is close enough that with technological advances, communication, or even travel might not be out of the question within the next century. For the first time in human history, we can plausibly envision a mission that sends data back from a planet orbiting another star. This idea was pure science fiction only a generation ago. Today, it's being actively engineered. The leap from science fiction to science reality is accelerating. But we must also acknowledge the risks, the uncertainties, and the ethical considerations. If Breakthrough Starshot or similar mission does succeed in reaching Proxima B, what responsibilities do we bear in sending probes or even microbial contamination across the stars? Do we risk altering an untouched world before we've fully understood it? Planetary protection protocols become complex in the interstellar context. Our curiosity is boundless, but with it must come wisdom. Our first contact with another Earth-like planet must be approached with reverence, not conquest. The golden record aboard Voyager reminded us to greet the universe with humility. That same principle must apply here. And beyond the technical, philosophical, and scientific dimensions, Proxima B's allure is ultimately emotional. It taps into something deep and universal. The yearning to not be alone. For millennia, we have gazed up at the stars and wondered if someone or something was gazing back. Proxima B gives shape to that wondering. It's not just a theoretical world. It's real. It orbits a real star. And it might be more like Earth than anything we've yet encountered. That is staggering. That is hope. If someday we confirm that Proxima B is habitable or even inhabited, the implications for our species would be profound. It would shift religious doctrines, philosophical debates, and national priorities. It would unify and divide. It would inspire and unsettle. But whatever we find, it is the search itself that defines us. In reaching across the void to a small rocky planet circling a dim red star, we are reaching for a deeper understanding of ourselves. Our tools, JWST, Breakthrough Starshot, the ELT, are extensions of our spirit, our intellect, our longing to connect. In the end, Proxima Centauri B reminds us that the universe is vast. Yes, but it is also intimate. The stars are not beyond our reach. They are part of our story. This exoplanet, just next door in galactic terms, invites us to keep asking, keep building, and keep hoping. Ultimate prize. Earth's abundant oceans are essential for its biosphere, and the possibility of water on Proxima B excites astrobiologists. If water exists, it could appear in multiple forms. Surface oceans on the day side, frozen ice caps in perpetual darkness, or even subterranean lakes insulated from a harsh environment above, much like those suspected beneath the ice shells of Europa and Enceladus. Spectral analysis using Webb may reveal water signature, but direct confirmation is still beyond our current reach. Some computer models suggest that if Proxima B retains an atmosphere, it could distribute heat between hemispheres, creating a tempered ring along the terminator, the twilight line separating day and night. In such a scenario, microbial life or even more complex ecosystems could adapt to the planet's unique rhythms. Proxima B also exists within a dynamic stellar system. Its host star Proxima Centauri is gravitationally bound to the Alpha Centauri binary, a pair of sun-like stars that along with Proxima form a trinary system. This celestial neighborhood is rich with potential, possibly housing other planets that remain hidden from our view. That's part of what makes Proxima B so culturally resonant. It's not just a promising exoplanet. It's a symbol,